We come to question number 12, where we are given a sequence where the first term is S1 equal to alpha, which is greater than 0, and the rest of the terms follows this rule. And we are asked to find the nature of the sequence and the limit. So let's start with the limit. Sn plus 1 square is equal to 1 plus Sn square by 1 plus alpha, or Sn plus 1 square plus alpha Sn plus 1 square is equal to 1 plus Sn square. Now, as n tend towards infinity, Sn square will tend towards Sn plus 1 square. So these two would cancel out. And alpha Sn plus 1 square will tend towards 1. Or in other words, Sn plus 1 square will tend towards 1 by alpha, or Sn plus 1 will tend towards 1 by root alpha. And as we saw, Sn will tend towards Sn plus 1, which will take the limiting value of root over 1 by alpha. So we can see from the options, option 1 and option C gives us the limiting value as 1 by root over alpha. So definitely 2 and 4 are ruled out. Now, to find out the nature of the function, we will have a look at the values of alpha itself. So alpha can take the value of less than 1, 1 or greater than 1. Now, when alpha is less than 1, for example, when alpha is 0.5, S2 would be root over of 1 plus alpha square, or S1 square, which is 0.25 by 1 plus 0.5, and this would be approximately root over of 0.83, or we can write S2 square itself, which would be 0.83. Now when alpha takes the value of 1, then S2 would be root over of 1 plus S1 square is 1, which is alpha square, by 1 plus 1, which would be 1 again. And when alpha is greater than 1, for example, alpha is equal to 2, then S2 would be root over of 1 plus 2 square, which is 4, by 1 plus 2, which is 3. So S2 square would be 5 by 3, or 1.67. Now, if you continue in this fashion, you will see that the values of S3, S4, etc. will keep increasing here, will remain constant for alpha equal to 1, and will decrease. So this will keep increasing, this will keep decreasing. So in option A and C, we can see both are monotonically increasing functions. So we have to take this particular case where alpha is less than 1. So when alpha is less than 1, 1 over alpha is greater than 1. And in this case, we have taken the value of 0.5. So 1 over alpha greater than 1 means if alpha is 0.5, 1 over alpha is 2. So therefore, the values of S2, S3 up to Sn will tend towards the limiting value of 2, or rather the squares of those values will tend towards the limiting value of 2, and the values will tend towards the root of 2. So therefore we can see that when the function is monotonically increasing and it has a limit of 1 over root alpha, then the values of Sn square will always be less than 1 by alpha. 1 by alpha in this case is 2, and you see all values of S2, S3, sorry, this is S2, S3, S4, all will be tending towards 2, which means that they will always be less than 2. So they will be less than 1 by alpha. So option A is the correct choice here. Question number 13. So this says that S is the sum of the convergent series defined by n 1 to infinity sigma of n, and we are given another series which follows the equation Tn equal to n plus 1 plus n2, and we are asked to find the sum of the series Tn from n equal to 1 to infinity. So this one will mean that we are trying to find the sum of n equal to 1 to infinity Tn, which is equal to sum of n equal to 1 to infinity. In place of Tn we write an plus 1 plus an plus 2. So this can be simplified as sigma of n 1 to infinity an plus sigma n equal to 1 to infinity an plus 1 plus sigma n equal to 1 to infinity an plus 2. So the first one is nothing but S, because sigma 1 to infinity an is equal to S. This is told. The second one, sigma n equal to 1 to infinity an plus 1 to infinity, would be S minus the first term, because we are taking all the terms from n equal to 1, means a2. When n equal to 1, this starts from a2 all the way to a infinity. This one is from a1 to a infinity. So the only difference between this one and this one is the term a1. So which means S minus a1. And similarly, the third one will run from a3 all the way to a infinity. So this will mean that this is S minus a1 minus a2, because it starts from a3, so it doesn't have the terms a1 and a2. It has all the other terms from a3 to a infinity except a1 and a2. So a1 plus a2 plus a3 to a infinity would be S, and if I remove a1 and a2, we get the remaining terms, which is what is given here. So S minus a1 minus a2 is this term. So if I add this 3 up, this is 3S minus 2a1 minus a2. So option D, it converges to 3S minus 2a1 minus a2 is the correct choice.